Hello, bonjour, and welcome to the Don't Waste Water podcast. I'm your host, Antoine Walter, and in today's episode, I'm super happy to welcome Kobe Nagar as my guest. Kobe is the CEO and co-founder of 374 Water, a cleantech company that specializes in supercritical water oxidation processes for resource recovery from waste and emerging contaminants elimination, like, for instance, PFAS. Water is a crazy thing when you think of it. It's said to be the solvent for life. Yet, that's not entirely true because it only is up to a certain point. And that certain point is what's called water's critical point, and it's reached at 221.1 bar and 374 degrees Celsius. That may already give you a hint at why Kobe's company is called 374 Water. But I won't spoil everything that happens beyond that point because Kobe will explain everything much better than me in just a minute. What I can tell you is that this process leverages the chemical energy trapped in wastewater. I did a back-of-the-envelope calculation and found that in municipal wastewater alone, there's about 1,600 terawatt-hour of energy, which is purely wasted today, which is the equivalent of 32,000 wind turbines that would be producing energy 24/7. Want to tap into that? Then hold on, we'll take off in just a second. Before that, let me remind you that if you like what you hear, please share this episode with a couple of colleagues and friends. I'm delighted to spend a bunch of hours every week to bring you the best pieces of water value on this microphone for free. All I ask is that you recommend it to your peers to help me grow our community. Thanks a lot for your support, and I'll see you on the other side.
You're listening to Don't Waste Water, the podcast that helps water professionals to improve their wastewater treatment, optimize their operation costs, and keep up with the latest market trends. This podcast is brought to you by GF Piping Systems. As a leading supplier of piping systems made of plastics and metal, GF Piping Systems is the global expert for the safe and reliable transportation of water, chemicals, and gas. For more information, visit gfps.com.
Hi, Kobe. Welcome to the show.
Hey, hi. Good to be here.
Well, we have a fascinating topic on our plate for today. So I have to tell you, I can't wait to really dive into it. But right before, I'm going to start with my good old traditions, which is the postcard. And your postcard comes from North Carolina. Am I right?
Yeah, my postcard coming from Durham, North Carolina, which is the home of Duke University.
What can you tell me about that place, which I would ignore by now, aside from it's the home of the Duke University?
So first of all, everybody is familiar with the Duke basketball team, but the first thing that I saw when coming here was a lot of trees around. It's a pretty green place. I think it's a really good place where you have talent from people from top university, but also the climate to really start and grow companies in the environmental space.
So talking of growing a company in the environmental space, that makes a smooth transition. You've been a spin-off out of Duke University. So you were a professor at Duke University, is that right?
Yeah, so I was part of Duke University. I wasn't a professor. They don't let me teach kids because I'm sending them out to do some real work. But I was leading a very fascinating project that we were able to turn into a company. I will talk about that and dive into that.
Before we discuss about this adventure, which is going to be our deep dive, of course, for today, I was trying to find, the red threads in your path. And the best I could find was you're into engineering stuff. Sounds like pretty obvious, but also on the unconventional side of things, like really scratching the unknown. Would that be a right definition, or would you have a better one?
I think it's a good observation. If you look in retrospect, I was always involved with industry that kind of pushed the envelope of the status quo. So, going back early on in my career, I was fascinated by rockets. Rocketeering was the thing that I wanted to do. But, after a couple of years in that industry, I discovered that the defense industry is not as glamorous as people think. And I like to say that, I turn into the bright side of the world of renewable and cleantech. I was very, very fortunate to actually work on geothermal energy and travel the world, see places, work on fuel cell energy. And before I joined Duke, I was actually in a startup that was doing cement out of CO2. And I think that can be a separate conversation for us. And then, going back to the university, and after 2 years, spun off a company, spun off 374.
So let's go back to that point in time where you do that spin-off. What I've seen is that there's a link with the Bill and Melinda Gates Foundation at some point. And what's the story? What did you find out which was worth spinning off a company?
So going back to 2018, I was still part in Duke University. I wasn't a professor, but at that time at the university, we were part of a project that was funded by the Bill and Melinda Gates Foundation as part of their Reinvented the Toilet challenge. And the focus was, how can we think literally outside of the box and take technology that at that time was very fringe and was geared into ammunition and chemical warfare destruction and bring it into the sanitation market. And really to give credit to the foundation, to the Bill and Melinda Gates Foundation, they've sparked a lot of new ideas and got people really excited about the wastewater industry and the importance of that. So, elevating that to a discussion level, that's a big credit to the foundation.
It's very interesting that you mentioned that because I had Aaron Tartakovsky on that microphone from Epic Cleantech, and he also was one of these spin-offs of the Reinventing the Toilet Challenge. And it's a totally different direction than the one you've been following. So it sounds like, it's an opportunity for many good ideas to go out there and to walk their way.
Yeah, absolutely. And there is a theory that, once you solve the extreme, then the solution for the media is much easier. And when we had to come up with a solution that will go into the developing world, you are forced to think differently. You're forced to think about how you can leverage the entire ecosystem to do what is best for the community, not just the individual part of how people are thinking about water and wastewater in today's world.
Let's dive into your technology and just have a last stop before we do that. Your company is called 374 Water. You're based in the US, which to my knowledge work with Fahrenheit and not with Celsius. So I was just wondering, why are you not called 705 Water?
Yes, so that's actually a funny thing about that. We actually had a short debate of calling the company 705 or 374 Water. And I remember at that time I was reading an article about movies that have the number 3 are more successful than other movies. But to me, frankly, the US is really big on the Fahrenheit scale, but to me it was invented just to have few northern countries not be below 0 half of the year. So, definitely Celsius makes more sense for engineers.
So actually, as we somehow spoiled it, the name of your company has something to do with the technology you're developing. And there is that very special things that happens at 374 degrees Celsius with water if you go also beyond 221 bar. And that is the critical point of water. And so far, on that microphone, we've discussed a lot of technologies and none of them have been to that extreme. So above this 374 degrees and above this 221 bar, which is the supercritical phase of water. What happens there and what got you interested in that field of behavior of water?
Yeah, so what happened in supercritical water is very fascinating. And let me go back because, for a lot of people, when we talk about the technology, and again, if we did talk to the technology for dummies, in order to make it simple, we say that we have a magic blue box where poop gets in on one side and you get water and energy on the other side. Yes, it sounds very good, but to take it down a notch, we are using this technology called supercritical water oxidation, which sounds very bombastic, right? But the only thing that people, and that's our job to educate, is there are two things that weren't told in school. One of them is everybody's familiar with the three phases of water being ice, liquid, and steam. But as you mentioned, like water have another phase called supercritical that happens above the critical point of water of 374 degrees C and 220 bar. It's not new, it's credit for the French. They discovered that in 1822. So, it's been 200 years. And then what's really fascinating about it, once you pass that point, water have an amazing properties that they can dissolve any organic matter, like acetone in room temperature. Again, keep in mind, we've always been told that water and oil don't mix. But surprisingly, they do mix very well in supercritical condition.
So let me try to understand that. That means that you have the normal behavior of water, which is it is a perfect solvent. You can mix whatever you want with water, and it doesn't mix with some stuff. And past that supercritical point, it's just the absolute opposite. It does the exact opposite from what it does below. Is that an oversimplification, or is that right?
That's exactly it. So the way I look at water is the solvent of life, right? There are a lot of things that water as a very basic molecule defy from a scientific perspective. This is another reason why water is such an interesting molecule. But it completely flips. So instead of water being a good solvent for salts, for inorganic, it becomes a very good solvent for organic molecule, but not for inorganic. That creates a very, very unique properties. And the second component of supercritical water oxidation is the oxidation. So once you add oxygen into the mix, then really the magic happens. Then you create this strongest oxidizing environment that can rapidly break any carbon bonds, including even the CF bonds that you have in PFAS. And when I say rapid, I mean seconds. We like to say it to people that we can convert the nastiest waste into water that you can drink in about 4 seconds.
Wow. We'll come back to the potential efficiency of your treatment. I just want to understand this oxidation as well, because we understood you placed that water in this supercritical phase, but now you need to oxidize it. You said you can do it with oxygen. You can do it, I guess, with air, which is 20% oxygen and 80% something else, or you can do it with different kinds of oxidants. And I saw that there are different takes at the technology on the market, and you are using air, if I'm right.
Yes, that's a great question on the type of oxidant that you can use. So the oxidation can happen with any type of oxidant source, and it can be pure oxygen, it can be even hydrogen peroxide or different type of oxymetals. But when we looked at the technology, we were looking on the developing world, where the infrastructure, the grid is lacking or doesn't exist at all, and we choose to use air, which is readily available anywhere. And that decision actually simplified the system and made it a lot safer. And later on, we found some really, really other cool benefits of using air.
Like what?
Like, things that are part of our IP portfolio.
Okay. So just for me to understand here as well, air, you're fully right, makes a lot of sense, is everywhere. So you have a compressor and you bring that air inside the system. I guess that makes it much more catered to any kind of field. Still, you have to bring your water to this 374 degrees, which I guess doesn't happen on your boiler. And same with the pressure, you have to bring it to this 221 bar. Is that complex, or is it also something which is pretty reachable?
I think it's complex, but it's also very simple, because in different industries, those are things that are being done in a very common piece of equipment. So if you take, for example, your diesel engine is running at a slightly lower pressure, but a much higher temperature. And it's all about having the system engineered to withstand that pressure. What really works for our advantage, and this is connected to how quickly the reaction is happening, is the size of the system is very small. So when we talk about the size of our reactor, kind of the heart of the system, we're talking about, a size of 1 liter per 1,000 people. That makes the entire system, very small, very compact, but mostly safe because you don't deal in with a lot of volumes here.
You mentioned your reactor as being the central part of your system. What's special about your reactor?
Surprisingly, nothing is special about our reactor. I'm saying that from a process perspective. I think, for a lot of people in the field, they start to romanticize on a hydrothermal flame that is happening and you capture that. But, I'm looking at it as a practical chemical engineer. So I'm looking at that as a chemical reactor. And in our case, we're using what is being called a plug flow reactor. That from a, again, volume perspective and cost perspective of the system is a very small and similar ratio to the heart of and the human body. So yeah, it's the core piece of our technology, but in terms of size, it's small and very compact.
So we have water entering, we have compressed air entering, then we have that plug flow reactor where this quite simple technology, if I listen to you, which is mimicking a bit of the body. And then what happens at the outlet? What comes out of that reactor after this very long 4 seconds where it reacts inside?
The beautiful thing about this technology, it's kind of, you can convert waste in a single step into the most elemental molecule. So when we take any type of hydrocarbon or any type of a nitrogen species, we can break it down to the elemental CO2, water, and if you have nitrogen, it becomes nitrogen gas. And really, the end result is you get water, you capture energy from the exothermic reaction, and the rest is very inert gas, so nitrogen, CO2, and all the inorganic minerals that were in the waste. And those minerals can be, reused, and in some cases, the value is big there because you have a lot of phosphorus.
Just before we go back to that, I think you just cracked a word which now explains everything about the energy. You just said the reaction is exothermic. So that means that you're producing more heat through the reaction than what you have to add at the beginning. Hence, the system can potentially be energy positive. Is that right?
Yeah, well, energy in is energy out, right? You can only lose energy in that equation. But what the supercritical process is capable is actually tapping into all the chemical energy that you have in the waste and convert it into heat. And we have shown that this is enough to sustain the reaction and actually produce power in a bigger scale system.
What would be the theoretical ratio there? If 100% is what you need to just sustain your system, to have a perfect balance, how much more could you, with scale, produce than the energy which you have as this base level? So are we talking of 105%, 120%, 700%? I know that's the theory.
No, so there is a trade-off between sizes of equipment and efficiency of equipment. So, for example, our smaller scale system is actually designed for 6,000 people. And on the 6,000 people, we are getting close to energy neutral, but there is still auxiliary equipment that needs to be run. Where we become a producer of electricity is in the 30,000 scale. And again, it all depends how do you account for that. So when we talk about energy positive, we're talking about the electricity positive. In terms of heat, you're always energy positive because you convert all of that to heat. So if you do a combined cycle or utilize the heat to heat up buildings or heat up water, you're positive from the get-go. But for most people, when they see waste, they're saying this is something we need to get rid of. When I see waste, I'm saying, this is the ultimate source of water, energy, and mineral. And one example, on a dry basis, our poop have this about a third of the energy that you have in jet fuel. So that's a lot of energy. The question is, how do we tap into it? And the supercritical water oxidation, we call it SCWO for short. So the SCWO process can tap into that. And to me, that was the reason I was drawn into this field from the first place. I was looking at that as energy, as an energy solution. And the challenge for us was, how do we simplify the system and make it user-friendly and ultimately autonomous?
That is a good thread. Let me continue that one. You said that the technology has been invented by the French, in 1822. Did I get that one right?
The concept of supercritical water was discovered by a Frenchman that I forgot his name now.
I'll find it. I have to battle for the French, so I'll put it in the episode notes. But from what I've read in preparing for that episode, I found many research papers around supercritical oxidation, or SCWO, let's use SCWO, in the 90s. And then there are some tries, and you have different companies left and right which are trying, which is usually a good sign, because if nobody tries, maybe they know something that you don't know. What's different about you that makes you potentially be the one which is going to be very successful with it, or which is very successful with it?
Great question. And we get it a lot because the technology was tried and invented back in the 90s. And I think, what helped us be successful is we really took the time. That's the beauty about starting in an academic institute. Like, we had the real pleasure on looking on what people have done before and trying to figure out what worked for them, what failed, and came up with a hybrid that took the benefit from both worlds. I gave the example of the air. The first system that were developed were based on air. And then the second generation that people have tried were based on pure oxygen. We were able to take those two thinking groups and figure out a hybrid that is using air, but using some of the elements that the folks that were focusing on pure oxygen were using. To me, that what made us successful. We had a very long time of developing the technology. The pilot that we have at Duke University has been operating from 2015, and it's all about pushing the envelope there. I always take, this is another point for the French. It's, if you look back on history, and I'm trying to correlate that to the wastewater industry, in a lot of sense, what we're doing in the wastewater industry is very similar to hot air balloons, or the technology that was, again, invented by the French in the 1800s, yeah. And then what we're trying to do is accelerate all of that and put a jet engine, also invented by the French about 100 years ago, into this industry.
So you're working for the French embassy, don't you?
I am. I'm getting something out of that. But yeah, if you look on technologies and companies in the wastewater industry, the big folks are located in France. The challenge is how do you get them motivated to adopt new innovation?
Okay, you were positive so far, and you had to be also realistic at some point.
Yeah. It's all about the balanced view. So
absolutely. I'm sorry because I'm dragging you a bit around, but I've cut you off when you were explaining the resource, because you said there are three pillars. There's the water element, there's the energy element, and there's the resources and the recovery of those resources, which is the third pillar of what you explained. And I cut you off when you were starting to explain that. So I'd like to get that part of the story. How do you recover those resources which you have been successfully separating from water, and what are the streams which you can generate with that?
The first resource that we recover is water. So we can generate water from any type of organic waste, and that's the first thing. In our system, what you get is half of the water is a distilled water quality, and then the other half is water that contains all the minerals. And it's all a matter of the market drivers about the value of those minerals, recovering those. I mentioned the fact that for municipal sludge, phosphorus is about 10 to 15% of those minerals. And it's very easy to recover. And on top of that, the entire mineral stream can be used as a fertilizer, as is.
So you have this resource recovery element, which allows you to drag the water and the resources. We also just touched on the efficiency of the removal that you have with your system. And you said it can break even PFAS. And I've seen in one of your case studies that you are breaking down PFAS to 99.98 or 99%, which sounds impressive. Is it something which is true for any kind of feed, or do you have to have specific conditions for that to happen?
So when we look on the process, we say our process it's feedstock agnostic. It doesn't really matter which kind of hydrocarbon you're feeding in. It can be fecal matter, fecal sludge, but it can also be any other organic like plastic or those PFAS molecules. At the end of the day, it's a molecule that have a carbon bond that you can break and get energy from breaking that bond. The same way that you burn natural gas. What's really unique about it is you do everything in a media of water. We go back to the fact that the water is the solvent of life. So when you do those reactions in water, you don't get the emission that you get from incinerating those material in air. And that's very important because one of the biggest challenge of eliminating PFAS in incinerators is at the end of the day, you get in HF or hydrofluoric acid, which is bad for the equipment, but also bad for the environment. In our case, what you end up with is fluoride, usually calcium fluoride, which can actually be beneficially used. Like this is the type of chemical that you have in your toothpaste.
Okay, so you're treating water with a high efficiency, you are potentially energy positive, you allow resource recovery, you use stuff which is available everywhere, heat and pressured air. I'm looking for a caveat, That sounds really too good to be true. So please, can you give me one limitation or one drawback to your system? Only one.
It does sound too good to be true. And, when I first joined the university project, I said, this is impossible. Like you guys are talking about stuff that very hard to do. But when you actually break it down and start sitting on the individual components, it's easy to do. I think what we're doing is all about managing the stream in, managing the stream out. And this is where we had to think about really how can you feed very viscous sludge into our system. So it took us several tries to figure that out. It's all about how do you make the energy balance work and be efficient. And it took us some years to figure out what's the right heat exchanger to use and how we can do that. And as you mentioned, back in the 90s, the biggest challenge with supercritical water oxidation is the fact that reactors and the materials for the reactor were pretty limited, and you had problem with corrosion. And then we mentioned the phenomena of supercritical water, that it's a not great solvent for inorganic. So you had plug-in issues. So we had to work really hard around those issues and how to solve those. Right now, the biggest challenge is adoption in the market. We know that the water industry is very risk averse. We have a saying that everybody in the industry want to be first to be second and do a pilot. It doesn't matter if you've done it over and over again. Everybody thinks that their waste is a unique snowflake and you have to try it again and again. The reality is we don't, right? And that's something that we're trying to change in the industry. Instead of doing a custom design that is a copy-paste from another design, we're trying to say, this is our system, it's been mass-produced, and this is the way you operate that. And it kind of simplified the process.
Talking of this adoption curve, which is, as we all know, one of the major hurdles in our industry, and we can debate because it's probably also for good reasons, not only for bad reasons. But what is your intended application? What is the part of the industry where people are dying to get your solution?
We mentioned the fact that the solution is very feedstock agnostic. So what we're catering is not just the utility, not just the municipal side, but we also taking care on the industrial waste. Right now, we are focusing on sludge and biosolids treatment because it's a big issue from a cost perspective, but also from emergent contaminants. And PFAS, a lot of folks talking about PFAS solution, but they're basically talking about removing PFAS. I think we are one of the only companies that are talking about elimination.
It's not separating the PFAS, it's breaking them down and eliminating them.
Yeah, it's actually moving them out of our ecosystem, breaking them down completely. We tend to joke that a lot of folks are doing basically PFAS sequestration that is really pushing the problem to another location or the next generation. And we're saying, no, let's think about how we can solve it. And there are some synergies. For example, when you treat biosolids, PFAS have an affinity to biosolids. So when you take and treat biosolids, you're taking, about 1,000 more PFAS molecules than water. So, you take that out of the environment. And I would say, our solution is in the business of minding pollution and taking the beneficial part of that.
But again, does that mean that the first place to use your technology is if I'm dealing with a complex problem and you're probably the best mousetrap, and even to a totally different scale, because you're not just trapping the pollution, you're reducing it, mineralizing it, and just eliminating it. But just to know the benchmark, what is the portion of the water industry you intend to disrupt and replace, to use the big words?
Yeah, so right now, we are basically competing with incineration and anaerobic digestion. And again, without even including the environmental benefits that we mentioned, we have shown that we can be lower CapEx and lower OpEx for both of those options.
So if you're lower OpEx, lower CapEx, and you have a difficulty for the early adopter to say, I want to be the first because everybody wants to be the second.
First to be second, yeah.
What is your business model there? Is it to sell your containers? Is it to offer them as a service, to rent them, or to deliver a treatment of water as a service? What is your model?
Right now, our job is basically reducing barriers to the industry. And this year, we are actually going to offer both, provide them as an equipment sale, but also provide service. What's really unique about our solution is you can relocate it. Just because it's small, it's containerized, that actually opens up another possibility of leasing our equipment. So instead of designing your plan for the next 30 years, you only need to design it for the next 6 months until we can deliver another module. Or if you have excess capacity, you can rent it out or move the entire asset to a different location. So it's opens up new and innovative business models around waste treatment.
Talking of new and innovative business models, I just saw that, when I was preparing for our discussion, I saw that you merged with Power Verde, which from the name has power inside. So I think that has to do something to do with the power generation or something around power, which sounds to me like a way to extend the business model and to say there's also the power element. But really, that is my helicopter view from the other side of the Atlantic. So what was the idea with this merger?
Yeah, I think you're right on point. For us, it was simple, a good alignment of the businesses. At that time, Power Verde were our supplier for the energy recovery piece. So, think about the supercritical oxidizers. We make a lot of heat, right? And we need to convert that heat back to electricity. So that's why we needed an energy recovery system. And that's what Power Verde had at that time. And we learned to, work with each other and then said, let's figure out a way that we can merge. And Power Verde is also being publicly traded. We wanted to use that vehicle to raise money. So we were successful in merging, but also raising money for the merged business together.
So that is a field which is, of course, fascinating, but I was just reviewing the numbers before we discussed. So you're publicly listed, and if I'm right, you're half a unicorn. Is that true?
Yeah, we are half a unicorn or a zebra. I'm a big believer in zebras. And kind of the horizon for 374 is really connecting the dots, or we call it connecting the drops between water, waste, energy, and food. That's essentially what we're gearing to do. So we want to be in those areas. We are connecting the technology into the water and waste and energy. And then the back end, the mineral and the heat is perfect for food production. So we're going to be and connect those for communities in a more decentralized ways than what's exists out there today.
That's an interesting vision. Does that mean that you might have more in the pipe? Because we've seen that in terms of scope, the fact that now you are together with Power Verde allows you to have everything which is inside the container basically is yours. But we could imagine that on that decentralized, distributed scale, on the agriculture or the food side of things, maybe you can also valorize these minerals that you gather and also transform them within one of your potentially subsidiary. Is that something which makes about sense, or do you really focus on what you do best and then you deliver the best components to the next company?
We have to focus, right? That's the challenge for a company. We have to focus about our core technology, but what's the strategy for us, on growing the business and growing that concept that waste is the ultimate resource, is to create a bolt-on technology that will come and provide that vision to, again, decentralized solution that will cater the needs on water, waste, energy, and food. So we're not going to do it ourselves. We have, an M&A strategy and partners that we work with.
If I look on the horizon, what are the triggers which will help you grow even faster? Because you said you took your time, but I would debate that, because if you did your first pilot in 2015, the usual timeline for a company in this water industry is to take 15 to 20 years to be in the middle of the market. You took 5 to 7 years to be half a unicorn. So I'm debating the fact that you're going slow, and I'm rather seeing that as you're going pretty fast. But I would see different triggers that could help you. If we say the water industry has to decarbonize, then the fact that you're energy positive and that you're not producing methane is very positive for you. If we start to go into resource recovery and we build the resource recovery routes, well, you're the perfect feedstock for those resource recovery routes. So what is your future driver, the future trend that you can ride to grow?
Yeah, it's definitely fascinating, right? Everything, and in order to be successful, you have to have the perfect time. It's all about timing in business. And luckily for us, we are hitting 4 of the critical element in the water industry right now. So, last year we were in WEFTEC, and one of the big questions that we had with the organizer is where to put the 374 booth, because we won the innovators of last year. We are focused on decentralized solution. We are focusing on PFAS solution, and we are focusing on resource recovery. So, you kind of answer 4 of those buckets in the company, and the market is really, really thirsty for a solution that can look at that from a more holistic perspective. And I believe that supercritical water oxidation is the key to achieve that.
Now, last question for me in that deep dive. I have my crystal ball next to me, and you can look in my crystal ball, and it shows you where 374 water is in 5 years. What tells you that you've succeeded when you look in that crystal ball?
Again, it's about targets that we put in front of us. So, the targets that we put for last year is to sell 2 units. And for this year, we are actually going and selling 10 units. And that's the target for this year. So it's all about pushing the company forward. The vision for me is to be the first for-profit company that is doing 100% ESG. And going back is really, really connecting that industry and connecting water, waste, energy, and food for a more sustainable future.
Well, I think that makes for a perfect tour of supercritical water oxidation and of what makes you special in that field, which is bubbling. And I have to say that you were on my bucket list of invitees, one of the people I wanted to have as a guest. But also your name came regularly from suggestions. So it's not like I'm the only one who wanted you to be on that microphone. So it sounds like you're onto something. It's not every day that I get a guest which is requested by the audience. So I think that's a sign. See it as you wish, but that's a sign.
I appreciate that. Yeah, we really try to do good in this world. Going back, and I think one of the questions that people are asking is, why did you create this? Why are you going against the giants? And it was mostly because the giants didn't want to develop technology. Originally we thought we will license the technology, but we realized after a year that most of the companies are not doing R&D. And when I saw that, I said, something needs to be done in this world. I'm looking on my kids, and I want them to have clean drinking water. And right now, the solution that we have in the industry are limited. And it's all about showing people that if you think about it from a more holistic and outside of the box, you can create a solution that will be more sustainable and more economical.
Actually, what you say on R&D makes me think of what Paul O'Callaghan was explaining on that microphone when we were discussing his thesis on the dynamics of water innovation. I was asking him because in his thesis, he shows that there's only a fraction of the companies which really invest into R&D. And to me, that's not obvious. I thought all the companies are investing in R&D, but it's not the case. And what he was saying is he was not blaming them at all. He was saying it's all a matter of return on investment. If you can prove that investing so much in R&D brings you so much and a bit more, then everybody would do it. But it's about having the right scale, the right fields, the right ideas, so that what you invest has a clear output in a sizable timeline. And from what I understand from 374 Water, that's probably your chance there, is that you're looking at a scale where you can see the effects pretty fast. You're surfing a wave, which is a tidal wave. I mean, what I mentioned about the resource recovery and the decarbonization is there to stay. And what you mentioned about the food, water, energy nexus, I mean, that clearly is also here to stay. So that places you a bit, if you're tracing a Venn diagram, at the center of that Venn diagram. And it's, I guess, a good place to be in. And I'm pretty sure you're not there by accident either. So
yeah, well, sometimes you need a little bit of luck to be in that specific Venn diagram, but luck is on our side. I think from being in the industry, seeing people, I think everybody in the industry, people are great. There are people that really care about the environment, people that want to do good, and it's all about recognition. I think the big companies are really challenged of facing failures, and if you take risk, you might fail. And that's something that mentally needs to be changed. You need to allocate at least a portion of your revenue into R&D and new solution, and really bring. It's good for business, but it's also good for the world, right? Because you need to advance society forward. And unfortunately, we weren't really picking the pace on water and wastewater, and that's going to change. It's going to change from people know and want to know more about water. Every conference that I go, I usually ask the crowd two questions. One is, do you care about water? And then everybody, of course, raise their hands. And then the second question is, do you know how much are you paying for a gallon or a liter of water? And then most of the people don't know. So how do we have a similar industry, the power industry, that every product you buy, you know how much kilowatt it consumes, you know how much it's going to cost you for a year, and it's part of the decision process. And electricity comes in one flavor. Water comes in many flavors. You have different contaminants, and people are not really aware of that. And that's part of our job is to educate the industry and really elevate the value of water. We treat it as a subsidized resource that is there, but the reality is very far from that. The quality is not there, and I always tell people, the water quality, for example, in Michigan can be worse than what you will find in Ethiopia. That's something that needs to be fixed.
I fully agree, but unless you have 2 more hours, I'm not opening that sidetrack, because that is a fascinating sidetrack. And the auditors of that podcast know that I can rant quite long about it. So I'm cautious of your time. But I take a note that that should be an awesome sequel episode at some point to discuss the value of water and the way we tell the stories of water and how we promote it. Because if people value it right, it's also a huge business opportunity which is created and which is a win-win for society. But as said, I'm not opening a rant. So I propose you to switch to the rapid fire questions.
It's time for the rapid fire questions.
So in that last section, I'm going to ask you short questions, which you can answer with short answers, and you'll see that I'm the one sidetracking. My first question is, what is the most exciting project you've been working on and why?
Yeah, I would say my kids are the most exciting project that I was working on. But you probably ask on the business world. Business world, definitely, 374 is a miracle. And it's all about how you transform a dream into a reality.
Can you name one thing that you've learned the hard way?
That it takes a long time for people to see and understand your alternative universe and vision. For us at 374, it took us almost 2 years to get the investor behind it.
Is there something you are doing today in your job that you will not be doing in 10 years?
I would say hopefully not work on the weekend, but it's a wishful thinking for an emergent company.
I get you.
I think it's more of a binary, right? You either get bought out and retired, or work as hard as you can.
What is the trend to watch out for in the water sector?
I think, again, maybe I'm a little bit biased, but having those couple ideas around water, waste, energy, and food. And again, this is something that I'm seeing. I hope that more people will see it.
If you were a world political leader, what would be your first action to influence the fate of the world's water challenges?
I would say, first of all, listen to scientists, right?
That's a good one.
Listening is a good action to do, but mainly kind of incentivize companies to sprout new ideas and innovation.
How would you do that?
So part of that, we talked about, how much of your revenue needs to be allocated for R&D. I would want to put some kind of legislation that will force you to do that. I'm coming from the mindset of, I was born and raised in Israel, and Israel is doing a lot in R&D. So a lot of the revenue, a lot of the reason companies are created and growing is because you invent in inventing the future.
Sounds like a good program. I would be voting for you as a world political leader.
Thank you. Yeah, one toilet at a time. Yeah.
Last question. Would you have someone to recommend me that I should definitely invite on that microphone?
I have one that might be hard for you, but I would want you to interview, the head of the EPA, Michael Regan, and get his perspective about, what needs to be done in the sector from a regulatory perspective.
Sounds good. I mean, when you said it would be hard, I was hoping you wouldn't recommend me Bill Gates, because that, I can tell you, is going to be really impossible for me. Can try, but awesome suggestion. Thanks a lot.
Yeah. Well, okay. So we'll talk about it offline. So.
Well, if you have his phone, I can take it.
I probably have like 3 tiers below him, but I think, if the right proposal will come, he might do it.
Interesting. You got me hooked. Well, Kobe, it's been a pleasure. Thanks a lot for sharing all of that with us today. I'll be watching closely the next path of your route. I mentioned you're half a unicorn. I'll let you build the other half, and then probably we have something to celebrate on that microphone.
Yeah, let's do it. Again, our goal is not becoming a unicorn. Our goal is to become a big company that really connects those dots and offer something else to the world. But we will celebrate.
You mentioned your bias, and that is my bias. I'm trying to see unicorns everywhere. Maybe it's because I have 2 daughters. I don't know if there's a link, but my partner in crime, Björn, called me a unicorn hunter. So it's good because I'm hunting something which doesn't really exist. So I'm still a good guy. But anyways, I'd be happy to have you again. So thanks a lot.
Absolutely. It was a pleasure. Thank you. Thank you very much. And keep doing what you're doing. It's a big part of educating the audience, and this is what we need in order to attract talent into our industry.
Thanks for listening to Don't Waste Water. This podcast was brought to you by GF Piping Systems. Loved this episode? Head over to Apple Podcasts to subscribe, rate, and leave a review. See you next time.